Alright, okay, welcome to this lesson with Teacher Kamanga. Now, in today's lesson in chemistry, we want to look at the nature of matter. Now, by definition, we're saying matter is anything that can occupy space and has weight. What we need to understand is that this means that, for instance, if you look at a cup, most of us we know that a cup, when you put water, you can even place it on the table. Now, when you place it on the table, you're going to realize that it will still occupy some space there. So you will realize that there is a cup there and it has occupied the space. Now, if you lift this cup, you are going to realize also that this cup is going to have some weight. Then the cup qualifies to be called matter. So we have various things on the environment that we can qualify to be called matter based on this characteristic. So for an object to be called matter, it must occupy space and also it must have weight. So those are the two justifications for an object to be called matter. So we see we have a lot of objects that they can be classified to be matter. Now, what we need to understand is that the same objects that we have on the environment, if an object, it is not a solid state of matter, then it should be a liquid. If it is not a liquid, it should be a gas. This means that we have the three states of matter, which we have number one solid, we have a liquid, and we have a gas. So these are the three states of matter that we have. Now, starting with when you look at a solid state of matter like we are seeing, you are going to realize that this solid state of matter, it is just a substance that has a fixed shape and also has a fixed volume. When you look at this substance as a fixed shape, meaning that this shape will not change. For example, when you look at a stone does not change its shape. You can carry it from one place to another, the shape will remain the same. This is what we mean when you say it has a fixed shape. When you look at the volume, the space which is going to occupy at a certain point, it will still remain the space which you occupy when you take it to another point, meaning that also the volume, it is still fixed. So this is what we mean. Now, when you look at these particles that we are seeing inside there, the particles are held together by the strong forces, which we call the intermolecular forces. Now, these forces are the ones that are making it possible that they can have what we call a fixed shape and also a fixed volume. These particles do not move, but they vibrate on their fixed position because of the strong intermolecular forces. So we need to understand that. Now, the other thing that we also need to know is that when we look at the same arrangement of these solid particles, we understand that that's why when you get a stone, you can throw it away, but the particles will not lose its shape. The shape will still remain the same. So we are seeing that a force is playing a pivotal role in terms of keeping the particles together. All right, so this is about a solid state of matter. Now, what we also need to understand is that the same solid state of matter, when you heat it, you introduce heat to this solid state of matter, it is going to change into another state of matter which we call a liquid. So when we introduce heat, it will change into what we call a liquid. Now, when we are trying to look at a liquid state of matter, for instance, let's try to look at this liquid state of matter. When you look at the particle arrangement is loosely packed. This means that the intermolecular forces that are holding these particles, they are loose or they are weak. They are not as strong as those in a solid state of matter. Now, what we also need to understand is that the shape of a liquid state of matter is not fixed. We can give an example. If you get water, you put it maybe in a jar which is round. You're going to realize that the water will also be round. When you get water, you put it in maybe a dish which has four corners, water will also change to be four corners. This means that the shape is not fixed. But we understand the volume is fixed. Why are we saying the volume is fixed? For instance, if you measure water, 1 liter of water, you pour it into a drum. Is the water going to change? No, the water will still remain 1 liter. This means that the volume is fixed. So we also need to understand. But when we look at the movement of these particles that are in there, they are able to move within their free space. That's why the particles in a liquid state of matter, they can slide against each other. You are going to realize that you are going to, when you pour water down, water will still be able to move, meaning that the particles are able to slide against each other. So we need to understand that. It's very, very important. All right. Now, what happens most if you get a liquid state of matter, you put it in the freezer. Maybe you can imagine you put water in a container, then you get that water, you put it in a freezer. We all going to agree that after some time, this water, it is going to change. How is it going to change? The water, which is a liquid, it will change into a solid because there would have a process of cooling that would have taken place. So we're able to understand that if we cool a liquid, it will change into a certain state of matter which we call a solid, which is the previous one from our discussion. So we need to understand. Now let's come to the third state of matter, which we call a gas. It is very interesting to know that a gas is very different from the two that we've already talked about. Why are we saying that? Because if you can look at the spaces between this particle to the other one, they have a very big space in between. This means that these particles are able to move within their free space. They move randomly in whichever direction. We need to understand, because they are not held by any intermolecular forces. Now, because of this, you're going to realize that their shape, it is not fixed, and also their volume, it is not fixed. When you look at a gas, if it finds a room, it is going to fill up that particular room. Like for example, we're looking at our earth, it is round. This earth, it is filled with a lot of gases, because these gases, they have no fixed shape. They will just fill up the available place. Okay, when you look at the shape as well, it is not fixed. For instance, if you're staying in a house which has four corners, you're going to realize that this house will be filled with a gas just like that. If you get a container which is round, you will realize that the container will be filled with the gas. So also the shape of the gas will just follow the shape of the containing vessel. So we need to understand that. Very, very important. Okay. Now, what we also need to know is that these three states of matter that we've talked about, they can undergo what we call physical change of state. Physical change of state. The reason why we're saying physical change of state is because we can be able to see that it is changing. So for instance, when you get a solid substance, like what I've just mentioned, you introduce heat to it, you're going to see that it will start melting. So that melting is a physical change of state, because we can be able to see that it is melting. A very good example is when you get ice. We all know ice. When you get ice, you put it on the sun. We know for sure that what will happen is that ice will change into water. So we are able to know for sure that from ice changing into water, we are calling it a physical change. So we're able to see. Now that change from a solid ice into a liquid water is what we call melting. So melting is a change of state of matter from solid to a liquid. So we need to understand that. Okay. We also have what we call melting point. So melting point is the point at which a substance is going to melt, or it is a temperature at which a substance is going to change from a solid to a liquid. Okay. We also have another process which we call evaporation or boiling. So evaporation, it is a change of state of matter from a liquid to a gas. That is what we call evaporation. So for instance, if you're boiling water on the brazier, it might be on the stove, you're going to realize that there will be some vapor that will be moving, the steam. So it is changing, that water is changing from being a liquid, it is changing into water vapor. That is the steam that we are seeing to be moving out. So we need to understand that. Okay, now, as that water is boiling, we also need to understand that there will be a point, as that water is mostly heating, you understand that there will be a point at which that water will start boiling. So that is the temperature that we are calling the boiling point. So the boiling point, in short, it is a temperature at which a substance is going to change from a liquid to a gas. So if a substance changes from a liquid to a gas at that particular point, it is called the boiling point. Okay, we also have what we call condensation. So this condensation, it is a change of state of a gas from a liquid. So from a gas to a liquid, so we need to understand that that is what we call condensation. So we've seen a number of times where we have just gases. Maybe it's when you wake up in the morning, you look at your window, you find a bit of some gases that are present there, maybe steam. Afterwards, that steam will be changing into or the mist. It's a very good example. Afterwards, the mist will be changing into water droplets. And also when you look at your lid, if you are cooking something, you put a lid there on the pot, there will be some steam that is going to be coming out. After removing the lid, you are going to realize that that steam will change into small droplets of water. So that is what we call condensation. Okay. Then we also have what we call freezing. So freezing, in this case, it is defined as the change of state from gas to a liquid. So when a substance is changing from gas to a liquid, then we're calling that one to be condensation. So now when we're looking at some substances that are maybe going to change from water to an ice, like the example that I just gave, you get water, you put it into a freezer, that is what we call freezing. Now there is a point or a temperature at which a substance is going to freeze. When you get water, you put it in a freezer, it will not just change direct into a solid, but what will happen is that it will be just changing gradually, but there will be a point at which that particular liquid will change now into a solid state, is what we call the freezing point. So the temperature at which a substance is going to change from liquid to a solid is one that we're calling a freezing point. Okay. There's also another interesting process which we call sublimation, where you are going to realize that there are some substances that are going to change from a solid to change direct into a gas, or from a gas it will change direct into a solid. So those substances are called are said to be undergoing what we call sublimation. So probably we have three substances that we need to know that will undergo sublimation. So the first one is iodine, the second one is ammonium chloride, then the third one is naphthalene. So these three substances are the ones that are probably able to undergo what we call sublimation. Okay, that is very, very interesting. All right, now our summary, we need to understand that these are the processes that we are probably talking about. So we are seeing this is a solid. Now, when you look at a solid, if it changes direct into a liquid, it is what we call melting. Now, if a liquid changes into a solid, we said this is freezing. So we need to understand the processes that are taking place. Then we have also a solid changing into a gas. This is what we call the sublimation, and also a gas can still change direct into a solid. We are still calling it sublimation. A liquid can change into a gas, which we are calling evaporation, which we are calling it evaporation or boiling. Then also a gas can change into a liquid, which we are calling condensation. So we need to understand that these processes are very, very vital to the three states of matter that we've just mentioned. So I'll urge you to prepare, look for questions that are pertaining to this so that we're able to see how we can apply this information in your answering of the questions. It has been nice with you. This is Teacher Kamanga. See you up to the next lesson.